Hello everyone, so welcome to my channel and I'm very nice to see you again. And today we are going to talk about the Logic Volume Manager, and we often call it the LVM. So in the future I will call it this LVM in this video. And this video will give you some basic instructions about how to manage your logic volumes. And at last I will introduce the mirrored LVM and compare the benefit between the regular LVM and the mirrored LVM. And at the same time I will provide you with something what the mirrored LVM can provide for us. And thank you for watching ahead of time. Before we move on to the topics, let's take a look at the basic structure of the logic volume. And from this picture we know that at the very bottom it is a storage of devices. Then we create the PV, the physical volumes, based on the storage devices. And many PV will construct the VG, that's the volume group, and then we create the logic volumes using the space from the VG. And then after we create the logic volumes, and after we format the logic volumes, we can manually mount the logic volumes onto the file system, and then we can use it on the system level. So I think that's the basic structure which can help us to understand what the logic volumes is from. This page will give you a more specific example, so where we can see that there's a VG named data VG, and which consists of several physical disks. About the VG, currently there are two logic volumes, and each of the logic volumes were mounted on the file system. And what's more, there is still some unallocated space for any possible use. Okay, then let's move on to the specific example I prepared for you. In order to help you better understand the LVM, here I prepared a test environment. That's where we can see that the EL7 was installed on this server. The EL7 means the Enterprise Linux 7. And in order to help us better understand the concepts, I already attached a new disk, a physical disk, to this server whose label is SDB, and the size is 2 GB. And at the same time, so also split this new disk into 4 partitions, and for each of which the type is Linux LVM. And never forget to change its type to Linux LVM, whose ID is E. And then let's get started. Of course, currently we have 4 partitions. So then let's create physical volumes by running pv create followed by for the path of the partition. And here we notice that the SDB1 has been successfully created. And at the same time, so we can put all the devices name in one single command line to save your time, like this: SDB3, dev, SDB4. In this case, all the PV has been created, and we can check the PV status by running PVS. And where we can see that we already create 4 PVs here. And after we created the PV, we need to create the VG with the PVs we created just now. The command line is VG create followed by the VG name. Here we call it data VG, and followed by the PV's path: SDB1, SDB2, dev, SDB3, dev, SDB4. We notice that this data VG has been created. Let's get the VG info. By running the jobs VGS, we can get the new VG's name is data VG, whose size is 1.98. That's similar to 2 GB. The data VG consists of the 4 PVs. At this time, so if you want to remove any one of the 4 PVs from the VG, you just need to run the jobs VG reduce, followed by the data VG, the VG's name, and the PV we want to remove from the WG. For example, we want to remove the STB3. So in this case, we notice that as STB3 has been removed from the data WG. Let's get the WG info by running. So the size has been reduced. And the PVS, we notice that the STB3 has been removed from the data WG. So in this example, we just want to have all the 4 PV to be the member of the data WG. So let's add it back by running WG extend followed by the data WG's name, and the WG the PV we just now removed from the WG. We notice that the STB3 has been added back to the WG. So let's get the WG's information. We notice that STB3 has been added back, and the size has been resumed to 2 gigabytes. Okay, after we created the WG, let's move on to create the logical volumes. The command line is lv create followed by -L and followed by the size. For example, let's create the new logical volumes with 100 megabytes size, and /n followed by the name. Let's call it data1, and the last put to the WG's name. So in this command line will create logical volumes whose name is data1 and whose size is 100 megabytes. Okay, after that, we notice that the logical volume has been created, and we just need to run LVS to check the status of the logical volume. We notice that data1 logical volume has been created, and the size is 100 megabytes. And before we use it, we need to format the logical volumes by running ext4 and followed by the path of the logical volumes we created just now. And then let's create the mount point on the file system. For example, we create the MNT data1, and let's mount the the logical volumes we created just now onto this file. So let's enter the MNT, the data1, and then let's check. We notice that the logical volumes data1 has been mounted onto the file system under MNT data1. So at this time, if you want to increase the size of the existing logical volumes, there are 2 different ways. The first one is you can run the following jobs to extend the LV extend, and we can also use the -L if you want to add another 100 megabytes to the existing logical volume. We just need to follow the give the path of the logical volumes. So this command line will increase the size of the logical volume data1 by another 100 megabytes. So we notice that it used to be 100 megabytes. Currently it's 200 megabytes, but the job hasn't been finished yet. You still need to resize to file s followed by the path followed by the path. So after this step, we still notice that the size has been updated to 200 megabytes currently. So we really demonstrate how to increase the size. There is another way to increase the size of the logical volumes. Just now we run this job. We run this job to increase the size by another 100 megabytes. For example, if you still want to add another 100 megabytes to the existing logical volume data1, we can run another job, lv extend -L, because after we increase another 100 megabytes, the size will become 300 megabytes. Never forget that there's no space between L and the size of the new WG. So we just need to run this job, and the difference is there's no space and no plus. So after we run this job, we notice that the size has been changed from 200 to 300 megabytes. And then the same thing, let's resize to fs data 1. So this time let's check the size. The currently is the 300. And currently, as we notice that for the VGS, we notice that there's still 1.7 gigabytes of space left. So, and currently we have only one logic volumes whose size is 300 megabytes. And if you want to use all the remaining space on the from the VG and assign it to the existing data 1 logic volumes, you just need to run the following jobs like ext dash smoke hazel plus 100%. Oh, sorry, 100% free, followed by the path. Data VG, data 1. We notice that this size has been changed from 300 megabytes to all the space to 2 gigabytes. Let's check. So the size of the logic volumes data 1 has been updated to 2 gigabytes currently. So at this moment, of course, the existing logic volumes has used up all the remaining space. So that's reduced the size of the logic volume, even though it is not suggested, because especially when there's a pretty much content or very many files is under the mount point. For example, here we notice that the logic volume has been mounted onto the mount data 1, and if let's create some file, some file like txt. Let's create some b2 text for 2. Notice that we already created some files. So usually we do suggest increasing the size of the logic volumes, but we do not often suggest reducing the size, of course, especially when there are very many files under the mount point. If you forcefully reduce the size of the logic volume, possibility that some files will be destroyed. So even though it is doable, let's reduce the size. Before we reduce the size, we have to follow the correcting order. The first order is let's unmount this file system. Of course, as we know, we just now mounted the logic volumes on the data 1. So let's unmount data 1. This is the first step, and then you have to let's check the logic volume before we actually reduce the size, and then let's resize it. For example, we want to reduce the size from the current 2 gigabytes to back to 300 megabytes. So we just need to put 300 megabytes here. Nothing to do with it. Currently the job is done, and then let's reduce the size. Reduce. The job is capital L space 300 megabytes depth, followed by the path of the logic volume. And there's a warning just suggesting that there's reducing the active disk logic volumes to 300 megabytes, and this will destroy your data. Are you sure you want to move on? Yes, we choose yes. We notice that the size has been changed from 2 gigabytes to back to 300 megabytes. Okay, again we need to check the file system again. To check the logic volume again, and then let's mount it back to the mount point. Data 1. Okay, let's enter the mount point. All the files is still there. And let's check the size. The size has been shrunk back to 300 megabytes. Finally, let's get to the last topic, which is about the mirrored logic volumes. And here, because just now we already created a regular logic volume as data 1, whose size is 300 megabytes. And we can get the detailed information by running the jobs like devices. We can notice that there's only one single line for the data 1 logic volumes. And we can see that all the files we keep in the logic volume data 1 will be kept on the SDB1 partition. And there's only single line for the regular logic volumes. And then in order to compare this, the regular one with the mirrored one, let's create a mirrored logic volume by running the jobs like LV create as we create regular one, and followed by the 100 megabytes. That's the size of the new logic volume. And here, what's the difference is we put the -m, which means this volume has the mirrors and it has backup. And here, let's put the 3 here. We specify a name, a data 2. At the last, we give the VG's name. And we notice that this logic volume data 2 has been created. And let's get the information. And we notice that we can clearly notice the difference between the two. The data 1 is regular LVM, but the data 2 is the mirrored logic volumes. And we can see that the difference between the two. We notice that there's a small case R for the mirrored logic volumes, and at the end of the mirrored logic volume, there's a 100, and we know that the 100 actually is the copy percentage sync. That means because just now we create the logic volume data 2 with 3 mirrors. That means we create this logic volumes with the 3 backups. So, and that means whenever we make any change on the data 2 logic volumes, it will take some time to synchronize all the changes across all the 3 backups. So here, the 100% synchronization means all the changes we made on the data 2 logic volumes has been synchronized to the other 3 backups. The number of the backup, and here we put the number 3 over here, and never forget that the number will be decided by how many PVs are there in the VG. And as we know that we created the data VG with the 4 partitions SB DB 1 2 3 4. So this we have 4 members over here. So this maximum number of the backup will be the PV's number minus 1. Here we have 4 PVs. So the maximum number of the backup will be 3. That's the 4 minus 1 equals 3. And of course, someone may ask me, so what will happen if we give a number larger than 3? Okay, let's try it. We can try to see what will happen. Let's create another logic one with 3, and we could go 4. And we notice that there's an error saying there's an insufficient exit. So we should ensure that this number is lower or equal to 3. At this moment, let's check the detailed information with devices. We notice that there is one single line for data 1 because the data 1 logic volume is a regular one, but there are several lines for data 2 because we create the data 2 logic volumes with 3 backups. So in total, there will be 4 set of data. So we can see that the data will be distributed across SB DB 1 2 3 4. And obviously we can see the difference between the mirrored logic volumes and the regular volumes. And someone also asked me if we could apply the mirrors to any regular logic volumes or not. The answer is yes. We can do it. For example, the currently data 1 logic volumes is regular one. If we want to apply the mirror to it, let's do it with convert followed by m. For example, let's create 2 mirrors for the data 1 and followed by the path, data 1 path. And then we will be asked, are you sure you want to convert to read one with 3 images enhancing resilience? The answer is yes. Okay, we notice that it has been changed, has been converted. Let's check it again. We notice that the data 1 used to be the regular one, but now it is also the mirrored one, and it also has the copy percentage synchronization. Let's get the full information about the 2 logic volumes. We notice that there's an item named mirrored volume. Here for the data 1, because we created with 2. So if we count the data 1 in, there are 3 for backup, but for the data 2 we have 4. So basically everything is good. And finally, let's check the status of the logic volume at the end of today's. So after we successfully applied these mirrors to the data 1, we noticed that the data 1 is currently have a 3 full set of the data. Of course, we create another 2 backup, except the data 1 itself. So currently everything is good, and all the jobs is done. And if you have any question, or if you think I can help you, so welcome to leave your comment under my video, and I will try my best to help you. And at the same time, if there is anything wrong with my video, strongly welcome to point it out, and I will improve myself in order to make my videos better and better. Thank you so much for your watching, and see you next time. Bye bye.